Hey there, it's Leo, welcome back for another video. Today, as promised, we're checking out tree procedural generation. In the main lines, it will consist in a C# script that will build a mesh step by step. As usual, you can find all the sources in the description. We will start by setting up a new scene and create two new materials for the trunk and the leaves. I'm gonna make a very simple shader graph so that the tree appears flat shaded. In my opinion, it looks better and it will be much easier to work with. You can see the edges and the faces of the triangles we're going to draw. Now let's observe how trees are actually made by Mother Nature. There are a few characteristics that make a tree look like a tree. The first that comes to my mind is the first branch height. If you want to make a baobab, this value should be really high, while if you want to make a bush, this value should be 0. We can also see the higher we go, the more the trunk shrinks. We will call that the reduction rate. Now let's head into the branches. If you cut any branch, you can see that it's actually a smaller tree on its own. We will call that a recursive aspect. This tree has a recursion depth of 11. Meaning that the most eccentric point has been through 11 splits before reaching its position. And finally, there are leaves at the end of any dead-end branch. So let's first focus on making the first part of the tree, the closest from the ground, which is basically a cylinder. As we want to create as many tree types as possible, we want to get control over the cylinder polygon base, as well as the radius of the tree. We can compare a cylinder to a building and consider it has several floors. And for each floor, we're going to compute the vertices position using the basics of the trigonometric circle. After we made the first floor, we need to make other floors. So first we have a floor height. We will shift all the vertices by a certain height, and then we're going to connect the new vertices with the previous ones through triangles. Triangles are represented by an array of vertex indexes. As long as we get the first floor right, we just have to repeat the process and connect each floor to the previous one. After implementing it, we have a decent cylinder generator. I don't create the top and bottom faces as we won't need them. Now it's time to work on the splits. As I said previously, any tree has a recursive aspect, meaning that we can implement it using a recursive function. Whenever a split should happen, I decide to create two new subtrees on the top of the existing trunk. I introduced a new parameter called branch density. The higher it is, the most likely it is to get a split at the current floor. The two subtrees will have different parameters than the parent one. We can see that the radius must decrease as well as the base polygon. For a hexagon-based parent, we can have two square-based children, but obviously there are many more ways to split than just cutting in half. Then we have to merge the different mesh coming from the different calls of the recursive function to get a single mesh. Luckily, Unity provides a combine mesh function that made things so much easier than they should have been. At that moment, we can already create recursive trees, but they don't look nice as they're twisted at the split points and they look way too straight. I started by adding a new property called twistiness that will randomly twist the trunk while it's adding floors to make it look more natural. I also introduced the distortion cone property that will make sure that our grow direction is not always toward the sky and every new branch will diverge from its twin branch. As you probably can tell, these two parameters made the whole difference. The trees are looking much more natural. But these twists around the splits are just wasting it. That was the toughest issue I came across, and fun fact, it was not solved at the moment I published my 100 tree package on the asset store. But for this video I managed to solve it. I had to rotate every floor according to the position of the split. And even if it's looking better than previously, it's still not perfect around the splits. To solve this issue, I found online a source code to smooth meshes. I will put a link in the description. Despite being very slow, it really helped me. And now the trees are looking great. When we look closer, we can see that we have way too many vertices and triangles. If you put a lot of trees, it will ruin your game performances. What I advise is to use a mesh simplifier. I'm gonna use Autolod, which is a tool I made myself, and that can do that task. As you can see, it significantly reduced the number of triangles, and it also makes the trunk look better with this kind of texture on it. The only thing missing now are the leaves. I want to keep things simple, so I decided to spawn a mesh on the top of every deaded branch. As a reminder, a deaded branch is a branch that reached the maximum floor number. I'm trying now with a cube, and as you can tell, it's working. And yet again, to keep things simple, the cube is not in a separate mesh. It's all in the same mesh, it's just a submesh. And the trunk is another submesh. Meaning that in the renderer, you just have to put two materials. The first will be applied to the trunk and the branches, whereas the second will be applied on the leaves. But don't worry, the script makes the setup automatically. I'm gonna use a sphere instead of a cube, but it's up to you. The sphere size will be proportional to the radius of the deaded branch it comes from. As a result, we have different spheres at the top of the tree, which looks kinda cool. Then I had another idea, to add a new parameter called roughness. The higher it is, the more it will displace randomly the vertices around where they should be, resulting in a noisy aspect on the trunk. It looks kinda cool, so I decided to keep it. Finally, I had some fun with the leaves shader. This is how the final version of the shader looks like. It's simple, but it looks great, I love it. Especially this dithering effect when you go inside the leaves. I will end up this video by playing around with a few parameters. You will see that we can get some incredibly goofy results. but who knows, you may need it in your game. That's it for this video. I hope you liked it as much as I did making it. Don't forget to subscribe not to miss the next one. See you next time. Cheers.